morning, students.
Good morning, sir.
Okay, this is a revision class in preparation for external exams that we are having ahead of us. And I want to say emphatically that what we want to do today is a revision process, a revision exercise of topics that are necessary, topics that you may encounter, likely encounter in your external exam. And that is why we are taking this time to go over this topic again, because it will definitely strengthen you to write your exam. I want to plead with my audience for total concentration as we move into this class. You will flash back to the fact that Longitude and Latitude has been taken in our different classes before. Yes or no?
Yes, sir.
And we took our time to go into necessary details about what you need to know on this topic. This morning, I'll quickly go through some important information again, at least to refresh our memory. On longitude and latitude, there are two basic types of circles. It is important for us to identify with these two types of circles. The first one is my small circle, and the second one is called the great circle. By definition, I've been able to give a summary definition that will make my student to identify with small circle as the question is presented, or to identify a great circle as the question is also given to us. Because without the strength of identifying with the two types of circles under this topic, a student will still be struggling to solve problems on longitude and latitude. Therefore, from my end here, I'll give a definition of a small circle. And I said a small circle is formed only when there are two or more longitudes placed on a single latitude. Sometimes ago, we also defined great circle. And our definition goes thus, that a great circle is formed only when there are two or more latitudes placed on a single longitude. That will take us to a diagram representation quickly of what a small circle is. This is a degree is longitude. K degree north, that's the latitude. Yes, there's another second latitude. Can somebody give me a letter for the second latitude now? P. Okay, let's take P, degree south. Okay, with that, we will now look at how to find distance between 2 points on a small circle, parallel of latitude of a small circle. We said you can use the formula theta over 360 times 2 pi small r. But the small r is the radius of the parallel of latitude. If a question asks you to find the radius of parallel of latitude, then you will know that radius of parallel of latitude also has its own formula that's capital R cos alpha, where your capital R is the radius of the hat, your alpha is the degree of the common latitude. But we have said the small r now is what? Is radius of the parallel of latitude. Radius of the parallel of latitude. Capital R, radius of the hat. The alpha is the degree of the common latitude. Then your theta is another parameter there. Your theta is angular difference in longitude. Angular difference in what? Longitude. In longitude. Okay. We can also look at how to find distance between x and y. The distance between 2 points on the great circle. For that, I think I can clean this one now. Knowing fully well we've been able to identify with a diagram of a small circle, then I can clean it to use this space for our great what? Great circle. Okay, for great circle, the distance xy is theta over 360 times 2 pi, a capital what? R. This theta is angular difference in latitude. Okay? The capital R still remains the same, is the radius of the earth. The parameters A. Looking at the parameters A, I can emphasize the place of theta, because as soon as we mismanage our theta, there's nothing else you want to do. It will spoil the whole exercise you are doing on solving the problem. So we must know how to get our angular difference in either longitude or latitude. When we say difference, it does not mean you have to subtract, basically. But some students will think, okay, since you said it's angular difference, that means we are subtracting. There are reasons when that will bring about subtraction. There are conditions that will bring about addition. But we need to identify with this condition and remind ourselves again quickly, for us to add, using this one now as a case study, this diagram as a case study. If you look at these two latitudes, are they on the same side or they are on different sides? They are on different sides. So the first condition is that you can have them on different sides. The second condition is that it is possible to have them on the same side. When they are on different sides, I said it is you add together. When they are on the same side, I said you should subtract. It is at this junction we need to take an example to establish the use of these formulas. It's important for us to take that example so that at least we can remind ourselves of some basic approach to solve the... Before I read this question, because you will need to write, students, are we set? Yes, sir. All right, so can we quickly write P, open a bracket, 40 degree north, comma, 18 degree west, close the bracket, and Q, open a bracket, 40 degree north, comma, 78 degree west. Close the bracket. Are two cities on the surface of the earth. There are two cities on the surface of the earth. Calculate A, the radius of parallel of latitude on which P and Q lie. Calculate A, the radius of the parallel of latitude on which P and Q lie. B, the length of the minor arc, PQ. The length of the minor arc, PQ. Correct to the nearest 100 kilometer. C, yes, that's where I will want to add my own question to it so that we can look at it at a go. Okay. C now, the length of chord PQ, correct to the nearest 10 kilometer. The length of chord PQ, correct to the nearest 10 kilometer. D, the angle that the chord PQ subtends at the center of the earth. The angle that the chord PQ subtends at the center of the earth. Correct to 1 decimal place. That's the question. Turn that question into a diagram. The first thing that should be emphasized when you are solving problem under diagram problems, which longitude and latitude is one of them. Please don't solve problem without drawing the diagram. It's important because diagram also attract marks. Don't solve problem without drawing the diagram. Okay, from the question, they said P is 40 degree north. I want to locate my 40 degree north. Yeah, that's a latitude, and that is my 40 degree north. This is my north, my south, and this is my west, this is my east. Okay, you also have 18 degree west. The longitude is 18 degree west. The intersection between the latitude and the longitude gives us point P. The second point, which is point Q, is 40 degree north and 78 degree west. Obviously, the same latitude now, that's 40 degree, but there is a new longitude, 78. The intersection also gives us what? Point Q. This is the diagram. That's the diagram for that question. They are now asking us to find A, the radius of the parallel of latitude. But before that, you will agree with me that with the definition of a small circle that says it's formed only when there are two longitudes placed on a single latitude. That indicates that this problem identifies with a small circle. So this problem is a small circle problem because I can see two longitudes and they have been placed on the same what? Same what? Latitude. Therefore, if it is a small circle, the first thing that should cross your mind, even when they are not asking you yet, is that the distance between P and Q is theta over 360 times 2 pi, a small r. Meanwhile, what is the first question asked in the problem we are solving? The first question says you should find or calculate radius of parallel of latitude. And with the introduction we have done, radius of parallel of latitude is small r, which is capital R because of alpha. For this problem, you are given your radius of the earth as 6,400 kilometers. That's capital R. And my alpha, with the diagram on the board, the alpha, which is the degree of the common latitude, is 40 degrees. By substitution, my small r will be 6,400 times cos 40. Somebody will help me from my audience to get what cos 40 is. 6,400 times 0.606. 7660. Okay, we now know that cos 40 is 0.7660. Okay, can somebody get the product? Or if it is not up to 5, then this number will be 4900 because he is saying this is 4,900. That's to the nearest what? 10 kilometer. To the nearest 10, please let's note that carefully. To the nearest 10 kilometer, you should look at the last number that is under the old number. Should be terminated to 0. But if it is 5 and above, it will not affect the next close number before you terminate it to 0. That's what we are saying. All right. We'll also look at something close in the next example, which is the B part. The B part says what? Length of minor arc. That's what I want to stress now. Length of minor arc. Of course, the principle we are looking at is also has been done under length of arc and under circle, where you have length of arc, where you have chord. You can still remember? Yes, okay, this is now asking us to find the length of arc PQ. Is the same thing as the distance between P and Q along the parallel of latitude. So, they are just using that as another way to frame that question. The length of arc is the same as distance PQ, which is theta over 360 times 2 pi small r. Meanwhile, our theta for this class, the second aspect of this question says we should find the length of what? The length of the minor arc PQ. If you look at this diagram, we should be used to this diagram where this is theta. This is a topic we have done before under circle where you find, of course, this will be small r. It's telling you this PQ is the arc of a circle, and the length of an arc is also the same thing as the distance between P and Q. So, if the question is saying the length of the minor arc, we still use the same formula, theta over 360 times 2 pi small r. With that, we want to come here now and check what is our theta from the diagram. From the diagram now, the two longitudes are on the same side. Yes or no? Yes, one is 78, the other is 18. So because they're on the same side, theta will be 78 minus 18, and that is 60. Shay? Yes, all right. With that, we can now go to the formula and substitute. Length will be 60 over 360 times 2 times 22 over 7. That has been given. If 22 over 7 is given to you, please don't use 3.142 times the value of r should be used, but it should not be the approximated value. Students, these are sensitive things that can affect your accuracy, and it will also reduce your mark. So please don't use approximated value in subsequent calculations. All right. So this will be 4902.4. Can somebody give us the final value? 12942. I don't believe that. 5,135.85 kilometer. My observation again, it is better for us to heed to this warning. Many students hold calculator, and they will still mismanage their calculator, and they are writing wrong values. The examiner will not press calculator for you as much as possible. It's expected of you to master how to use the calculator and use them correctly. Okay? If you want to solve this now to the nearest 100 kilometer, 5135 point, of course, decimal place is not that, the whole number is 5135. Nearest 100, if you write your 100 this way, it shows that 35 should go. if let's assume this is 7, 5175, your nearest 100 kilometer will be 5200. But obviously, this is not up to 5, so you have 51 what? 51 what? Nearest 100 kilometer, 5100 kilometer to the nearest 100 kilometer. Are we still together?
Yes, sir.
Okay, I want to manage my space carefully so that we can look at it together as a whole question. The next question says what? Length of chord what? Chord what? There's a difference between a chord and a what? An arc. An arc is what? A part of a circle. Yes or no? Yes, so it is like you are taking 2 points out on a circle. Obviously, that is an arc. But a chord is what? It's a straight line. Thank you. That's the first thing you will establish. It's a straight line that is joining 2 points together on the circumference of a circle. So we assume that this is part of a circle. If I join these 2 points together, that length is becoming a chord. Am I still communicating? Yes, sir. The length, we want to find length or the length of a chord PQ. Shebi? Yes, sir. All right. With that, if that is the length of the chord, there's an aspect of circle that has been taught before that says that a line drawn from the center of a circle that meets with a chord is perpendicular to the chord, and it divides the chord into 2 equal halves. It's a theorem under circle geometry. That's the first main theorem that students of this class should have learned on circle geometry. Okay, if that is the case, what is the angle here? The angle here is our angular difference in longitude, which is what? 60. It is also said in that theorem that this line drawn from the center of the circle bisects this angle and is perpendicular to the chord, and is dividing the chord into 2 equal halves. That means this space will be 30. This space will also be 30. The R here has been calculated as what? 4902.4. Remember, we have calculated that small r. Should be now? Yes, sir. All right, with that, we can get, using this, if you have a triangle that has angle 90, it's called what? A right angle triangle. So when you have a right angle triangle, what is the main application that should cross our mind? That's trigonometric ratio. Okay, so under that, if I want to use this space, I will just show you here that this is what I'm bringing out. This space is 30. This place is my center O, and let's call this place M. This place is my M now, and this is what? P. The angle there is 30. This is 4902.4. It's in kilometer. They want me to find this place. Let me call it K. Opposite of this angle over the hypotenuse, because this is a right angle, then I have sine, opposite over hypotenuse, that's sine 30 is equal to K over 4902.4. It implies that K is 4902.4 times sine 30. Sine 30 is 0.5, and this is 4902.4. Finally, 2,451 kilometer. Nearest 10 now will be 452,450. 245 what? 0. Kilometer. 2450 kilo what? Kilometer. That's to the nearest 10 kilometer. Am I still communicating?
Yes, sir.
All right. The last question under this observation is what?
The angle that is called PQ subtends at the center of the S.
Oh. Before we leave that, it is just the half we have gotten. We want to get chord PQ. So to get chord PQ, before we approximate, to get chord PQ, we need to multiply this by what? So PQ, thank you. PQ will now be what? Multiply this by 2. 4 what? 4902. Interesting. So this, we are just emphasizing a process. They can ask you to find the length of an arc. They can also ask you to find what? The length of what? A chord. Okay. For that, I think we are done with. To the nearest, of course, that will be 4900 kilometer. The last aspect of that question says what? The angle that, with what? What does that mean? What does that mean? Because that's another thing that can be funny. What does that mean? It means you want to find the angle that represents the angular difference of a great circle. You want to find the angle that represents the angular difference for a great circle. And that will be theta prime is equal to 2 arcsine cos alpha sine theta over 2. The theta that will be that this will subtend here is talking about theta of a great circle, not that small circle again. It is another way to interpret it is that you are talking about when you are given a small circle and they are asking you to find its great circle distance apart. Sometimes ago we have established that too. That it is possible for you to have a small circle, yes or no? And the question is saying find the great circle distance apart. And I called your attention that you must calculate that angle separately first. If it is a small circle, the first thing you must do is calculate the angular difference using this formula first. Then you can now use the formula that says theta over 360 times 2 pi capital R. Please, am I still communicating?
Yes, sir.
So, but you are not finding distance along this circle, it's just the angular difference now is that we are finding here. 2 into what? Arcsine. What's cos alpha? That's cos 40 times what's theta? 60. So that will be sine 30. So you have what here? You have 2 into arcsine 0.7660 times 0.5. Which is what? 2 arcsine what? 0.383 what? Okay. So, what's the arcsine of this? 2 times 22 point what? 59. Okay, 5196. Multiply that by 2. You have 45.03. Okay, let's leave it as 45.04 degrees. That is the best answer. To one decimal place, 45.0. To one decimal place, 45.0. Students, we have been able to go through one aspect of, one example that has at least taken us through the application of some formulas you need to remind yourself of under longitude and latitude. I want to encourage us to please go back to all that we have said before and check those things also in, out, as we prepare for our external exam. Thank you.